So here we go. I'm picking, I picked 15 problems for this review for the exam. And I think it's important that you understand these problems. Now, this is just a very good approximation of what the exam is going to look like. Here, let me mute people so that you guys can be prepared for this. Now, do you guys want me to run this in a way that I give you an opportunity to try these problems, or do you just want me to do them? I'm fine either way.
Could you just like pause at the critical parts and let us try to work it a bit, but not like too much where we lose time?
Okay, that's fine. All right, so here we go. So exam 2 review. Let's do this. All right, so this first problem is going to go like this. So this is number 1. It's the integral of t cubed ln of t dt. All right, so I'll give you guys a quick second to try it, and then I'll do it. Or actually, better than having you do it, just looking at this problem, it's better to discuss it, I think. What do you think the method should be? What's your gut reaction to what the method should be for this problem?
Integration by parts?
Yeah. Yes, it's going to be the UV substitution, right? So our integration by parts. So as soon as we see this problem, we see it's an integration by part piece. Now we have to decide what's our U, what's our dV. So what would our UV be? That's funny.
ln.
So our U should be ln of t, right? So our dV should be that t cubed dt, right?
Right.
This will lead us to du is 1 over t dt. Our v will then be 1/4 t to the 4th, correct?
Right.
Okay, so then from here we have to remember that it's uv minus the integral of v du, just so everyone can recall. So my u times v is going to be 1/4 t to the 4th ln of t minus the integral of v du. So v du is going to give me a 1/4 in front. The t's will cancel, so I'm going to get t to the 3rd dt. Are we in agreement?
Yeah.
Mm-hmm.
And so this will yield 1/4 t to the 4th ln of t minus 1/16 t to the 4th plus some constant c. Don't forget the constant c, right? This is indefinite, and since it's indefinite, we must have our constant there. And this is our first answer. Pretty good, right? Straightforward.
Yeah.
All right, let's try the next one. So if I give you the integral of e to the 2 theta sine 3 theta d theta, what's your gut instinct tell you here?
It'll be U substitution again.
A U substitution. If we do a U sub here, what would be eliminated? Don't we see this as a product here? And since it's a product, I think it should be again a UV, integration by part.
Yeah.
Okay, since it's an integration by part, what would my u be?
On 3 theta? Or is that an 8?
It's a 3. Here, let me make that right for you. Sine 3 theta. So you want to go with sine 3 theta here? That's okay. So when we go to do this here, if I go du, aren't I going to get cosine 3 theta times 3 d theta?
Yeah.
And then here I'm going to get 1/2 e to the 2 theta. Do we agree?
Yeah.
Okay. So then from here, again, I'm just going to write the rule for all of you. V du. I'm going to get, I'm going to get u times v. So that's going to give me 1/2 e to the 2 theta sine 3 theta, right? Minus the integral of v du. So that should give me 3 over 2 e to the 2 theta cosine 3 theta d theta, right? And what do we see is going to happen here? Doesn't this second piece have to have another uv?
Yes.
Yeah.
Okay, so then if that becomes a uv and we do the same thing, okay, it's going to be cosine 3 theta, dv is going to be e2 theta. I think you guys already see what's going to happen, right?
Is it going to be a repeater?
It's going to be a repeater, right? Because what's going to end up happening, I'm going to have, okay, 1/2 e to the 2 theta sine 3 theta minus, and then we have to remember this 3/2. Don't mess that up. That's where people will make their mistake with this problem. So it's going to be u times v, which is going to give me e to the 2 theta cosine 3 theta minus the integral. But there's a negative, so it's going to become a plus, right? 3/2 e to the 2 theta sine 3 theta d theta, right? Now let's distribute that 3/2. So I'm going to get 1/2 e to the 2 theta sine 3 theta minus 3/2 e to the 2 theta cosine 3 theta plus 9/4, oops, that should not be a plus, minus 9/4 the integral of e to the 2 theta sine 3 theta d theta. But that will end up equaling 13/4 integral of e to the 2 theta sine 3 theta d theta is equal to 1/2 e to the 2 theta sine 3 theta minus 3/2 e to the 2 theta cosine 3 theta, correct?
Yes.
Any questions on how I got that 13/4?
Yeah.
Okay, so we got to remember that our original problem was this, correct? Right? In the original problem, we had this. So this is on the other side. So really what we have is an equal sign here with that integral. And I'll write it so you guys can see. Integral of 2 theta sine 3 theta d theta, right? So when I move this piece over, it's going to add 9/4. So 4/4 plus 9/4 is 13/4. Agreed?
Agreed.
Okay. Okay, and then I'm going to multiply by the reciprocal. So I'm going to get 1 over 26, if I'm correct. 1 over 26. E2 theta sine 3 theta minus, again multiplying by the reciprocal, I'm going to get 3 over 26 e to the 2 theta cosine 3 theta. And then I have to add a plus c.
Okay.
Did I get that right?
Yeah.
I believe so.
Okay. Well, that makes sense.
Yeah, so it's just a repeater. Now, your answer would have been slightly different had you switched your u and dv. Because remember, you can treat the exponential as a log, and so you would have called that your u. So your answer would have been different, but it ends up being exactly the same value, which is weird. But I always use my hierarchy that I have, and so my answer is going to be slightly different. WebAssign will be fine with it. Okay?
Okay, question.
Sure.
So is it just, well, like in this instance where we came across a repeater that we would, well, consider the original integral and then use that?
Correct. So whenever you have a repeater, you have to remember the original problem. Because you end up seeing when you got to this point right here, you're like, oh man, that's the problem itself, right? So you have to recognize that.
Okay.
Right?
Right.
Question about the work.
What's that?
So on the second to last line, you have minus 3 halves e 2 pi, or sorry, 2 theta cosine 3
Here?
theta. Yeah. I was wondering how you got that 2 in there, the 3 over 2. I got the 3.
Here?
But I can't find. Yeah. Where'd that come from?
Oh, okay. So let me see if I can. So that's this piece right here,
Oh, okay.
right? Which comes from here.
Oh, because it's, never mind.
Does that make sense?
Yeah. Thank you.
So the flow here, I can do this for you. This yields this, which yields this.
Yeah, I just didn't follow it properly. Thank
No,
you.
no worries. That's why it's proper for you to ask a question, right? Does that make sense now?
Yes.
All right, cool. Okay, next problem. So integral of sine cubed theta cosine 6 theta d theta. So this is one of those rules, right, where we have an odd and an even function. What should we do?
Break it up.
Break it up. Okay, cool. So if we break it up, what are we going to do? How do you want to do it? We break up the
Sine
odd
squared.
function, correct?
You get a sine squared and then sine.
Correct. So we should get this. And now what?
Can we break the cosine to the sixth into the cosine squared cubed, I think it is?
Well, we could make it even easier than that. Just do this. Go 1 minus cosine squared theta, cosine 6 theta, sine theta d theta, and go u is cosine theta. Because when we take the derivative here, don't we get negative sine theta d theta, which takes care of the sine theta?
Yes.
So we end up with negative 1 minus u squared, u to the 6th d theta. Or, oh, I'm sorry, du. And now we can just distribute, right? And this becomes a power rule integral. Agreed?
Agreed.
So I'm going to get negative integral of u to the 6th minus u to the 8th du. So that should be u to the 7th over 7 plus u to the 9th over 9 plus some constant c, which will be negative cosine 7 theta over 7 plus cosine to the 9th theta over 9 plus some constant c. Merry Christmas. We got it. We okay?
I just want to ask, Professor,
Sure.
where'd you get the -1 that's outside of the integral? Where did that come from?
From right here. So do you see how the derivative of cosine is going to be negative sine, correct?
Yes.
So then that's negative du is sine theta d theta. So when I replace my sine theta, du has to have a negative with it.
Okay, I see. Thank you.
Yeah. No problem. We okay?
Yep.
People are like, sir, don't ask those questions right now. It's not cool.
It's a deeper answer than that.
Yeah. No, 100%. I understand. Like, 100% I get it. Come in my office hours. I'd love to help you. All right, here's the next one. So the integral of 4 tangent of x secant cubed of x dx.
The cubed or squared?
Yeah. You said cubed, but you wrote squared.
The secant.
Oh, you know, sometimes I speak different than what I do. Thank you for that. That was David, right?
Yeah, and someone else.
Man, why you guys try to correct me? That's not cool. No, I appreciate it. So what can we do here?
Well, you could break it up.
Okay, cool. What should I break up?
Well, the secant to secant squared secant.
Okay, so I could go here. I'll pull the 4 out. Go tangent of x, secant of x, secant squared of x dx. Good. Then what?
Well, u sub
Okay, what's my u?
secant.
Very good. So that's going to be du is secant of x, tangent of x dx. That takes care of what's in front of the secant squared. So I should get u squared du.
Easy money.
That's right. So I'll get 4/3 u to the 3rd plus some constant c. So it should be 4/3 secant cubed of x plus c. We all right?
Is it going to be this simple on the test?
Yeah.
Well, the interesting thing, the interesting thing about what you just said there is you've got to remember I'm doing it right now. So a lot of pressure is off, right? When you're doing it, you're going to feel a little bit of pressure, but yeah, there's not going to be a drastic change to what we're doing at all. All right? Okay, so let's do the next one. Here, I'll write it on the next page so it's not cut off. Here we go. We have the integral of square root of x squared minus 49 over x cubed dx. What do you guys think?
Would we start with u sub?
If we did a u sub, what would we u sub?
The square root.
But if we do that, how do we get rid of the cube? I mean, we could go down that slippery slope if you'd like, but it might be preferable to do a trig sub. Right? And this is where you guys knowing your trig subs becomes so important. We would go x is 7 secant theta. Right? So knowing your substitutions for your trig subs becomes so important. Because look what happens here when we do this problem. I take the derivative, I'm going to get 7 secant theta tangent theta d theta, correct? So that's going to take over for dx. So I'm going to have 49 secant squared theta minus 49 under the root over, I'll just leave it as a cube, 7 cubed secant cubed theta times 7 secant theta tangent theta d theta. Are we in agreement?
Yes.
Okay, so that top piece, doesn't that become tangent, 7 tangent theta? Right? This becomes 7 tangent theta. Agreed?
Agreed.
So I have 7 cubed secant cubed theta, and then I have 7 over here secant theta tangent theta d theta. So we can get rid of some 7s, right? So I'm going to have 1/7 out front, and I'm going to have a tangent squared theta over, it looks like a secant squared theta d theta. Agreed?
Agreed.
Okay, and that should be 1/7 the integral of sine squared theta d theta. That might be a jump for some of you. Let me know. I can show it.
Shouldn't it be a 1/49? Because there's still 2 7s at the bottom.
This 7 takes one of the 7s. This 7 takes one of the 7s.
Oh, I didn't see. Okay.
Does that make sense?
Yeah, I didn't see that one.
All right. No worries. Does everyone see how it's sine squared?
Yeah.
Okay, cool. So then from there, we have to remember there's a rule I gave you for sine squared and cosine squared, right? Remember I called it the power reduction?
Like 1/2 1 minus cosine 2 theta.
2 theta, that's right. So what we're going to end up with is 1/14 integral of 1 minus cosine, oops, not squared, cosine 2 theta d theta. Agreed?
Agreed.
So the integral of cosine is going to be 1/4. The 2 is going to go to the denominator, so I should get 1/28 sine 2 theta plus some constant, correct?
Correct.
Okay, I think that's
Can we
right.
break up the sine 2 theta?
What's that? I'm sorry?
We break up the sine 2 theta into 2 sine theta cosine theta.
Oh,
Or
no, 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 I won't do that. I mean, I can. I can do that if you'd like. But what I'm going to do is, well, yeah, it's probably easier when we do the substitution for our trig, right? When we do the triangle. So we can do that. So let's say it's 1/14 theta minus 1/14 sine theta cosine theta plus some constant c. And now we need to go to our triangle, right? And in this triangle, we had x was equal to 7 secant theta, correct? So then x over 7 is equal to secant theta. So secant theta was what? It's cosine is adjacent over hypotenuse. So this is hypotenuse over adjacent. So this is this, and then we have our x squared minus 49. Agreed?
Agreed.
So now, when we go to get our theta, we should get 1/14 secant inverse of x over 7 minus 1/14. Sine is going to be opposite over hypotenuse. And cosine is going to be adjacent over hypotenuse. Oops, why did I... That should be an x. No, that's right. Right? And then let's not forget our plus c. So when we clean this up, it should be 1/14 secant inverse of x over 7 minus 1/2. Actually, I'll clean it up and write it as one whole thing. I'm going to get root of x squared minus 49 over 2x squared plus c. Agreed?
Agreed.
All right.
I have a question.
Yes, please.
How do we go from 1/20 sine to 1/14 sine?
From here to here?
Yeah.
Okay, so this here has a rule, right? So the trig rule for that is sine of 2 theta is equal to 2 sine theta cosine theta. And that's what I did. I changed the sine 2 theta to sine cosine. Do you see that in the next step?
Okay, yeah.
Yeah.
Thank you.
Yeah. Here I'll highlight this just so you can see. That's why that became 1/14 instead of the 28. We're good? Are you guys ready for the next one?
Still writing it down.
Okay, no worries.
Not yet.
Will you be posting these notes on Canvas?
To post these notes?
Yeah.
Yeah, I'm going to post this on Canvas right after
Okay.
class. It'll be immediately up after class.
All right, thank you.
Because I don't need to, the recording will take some time, obviously, but the notes completed will be put on there right away.
Okay, thanks.
Yeah.
So the 7 and the 14, those cancel out, and then you get a 2 on the bottom, right?
Correct. Yes.
Oh, okay. I didn't. Okay, cool.
Yeah, because all that gets multiplied together, right? So you'll end up with 7 square root of x squared minus 49 over 14x squared, but then the 7 and the 14 obviously reduce.
All right. Cool.
I shouldn't say obviously, they reduce, right? Like, that's,
Just so
I'm not
make
trying
sure
to be
I'm following.
insulting. Huh?
Just to make sure I'm following, the root x squared minus 49 over x, that's coming from sine theta, and then the 7 over x is coming from cosine theta, right?
Correct. So when you look at this piece is sine, this piece is cosine.
Okay, thank you.
Mm-hmm. Isn't calc fun, guys? Aren't you guys like, hell yeah, I'm glad I signed up for this?
I live for this day. Every week, these are my favorite days.
Oh, there you go. Are you a math major?
No, I'm a STEM major, but it's not for math.
Oh, that's cool. Hey, this is the purest thing, man. But it's...
Pretty satisfying when you get it right. So.
It is. And it's devastating when you get it wrong.
Sometimes it's just so dense.
Yeah. Right? Sometimes you're like, wait, why didn't I see that? But I will get there. And remember, you do get a page of notes for the exam. So there are some rules that you guys should have down and know how to use them. Okay? All right, can I go on to the next problem?
Yes.
All right. So what are we on? Number 6. Okay. Again, I don't want to cut it off, so I'll go down a page. So this might be like 80 pages. Sorry. All right, here's the integral of du of u square root of 3 minus u squared. So again, we can tell this is going to be a trig sub, right? But it's not a pretty one, unfortunately, because our 3 there isn't a squared number. So when we go to do the trig sub, we're going to get root of 3 sine theta. We okay?
Yes.
There's a lot of quiet cats here.
Meow.
That's classic. Okay, so let me go ahead and do the substitutions then. I'm going to get the integral of square root of 3 sine theta then root, and I'll put this up above. This will be 3 minus 3 sine squared theta. Are we okay with that?
You just square the u. Oh, yeah, man.
We okay with that?
Yeah.
All right. So then from there, that's going to become, before I start eliminating a bunch of things, I'll just rewrite it so it's clean for you guys. And I've converted. Do we agree?
Yeah.
So the,
Yes.
the cosines in one of the root 3's are going to go. So I'm going to have 1 over root of 3. And then it's going to be 1 over sine, but 1 over sine is what? Cosecant theta, d theta. And this is the other one that had the trick. Remember I told you when we did secant, we multiplied by secant plus tangent? The trick on this one is to multiply by cosecant minus cotangent, top and bottom. So I'm going to show that to you guys. I did this intentionally so you guys could see me do it. Trying to be as fair with you guys as I can and not spring stuff on you. Right? And so what do you think we do here? Well, I'll write the next step just so you guys can see it. My u is going to be the denominator. So the derivative of cosecant theta is what?
Negative.
It's a negative what?
Cosecant squared theta.
Cosecant theta cotangent theta. And then this becomes a negative cosecant squared theta, which a negative and a negative become a plus. And don't you see that that is the numerator? Right?
Right.
And so I'm going to get 1 over root of 3, square root of 1 over u du. And the integral of that is?
Natural log.
Natural log. So I'm going to get 1 root of 3 natural log of u plus some c. But now we need our triangle, right? Because we're going to get 1 over root of 3 natural log of cosecant theta minus cotangent theta plus some c. What was our u? Our u in this case when we started was radical 3 sine theta, right? So this is 3. Oh, I think, was it u that we used? I forget what it was. I think it was u. Whatever. I think we used u again. Bummer. That's u, so it's opposite, right? And then this should be 3 minus u squared rooted, with this being my theta. Any questions on that triangle? No? We're good?
Yes.
All right, so then we're going to go and I'll try to see if I can get this, I'll get it fit in here. I'm going to get ln of cosecant theta is the reciprocal of sine. Sine is opposite over hypotenuse, so it should be hypotenuse over opposite. So hypotenuse over opposite minus cotangent, which is adjacent over opposite, so that should be 3 minus u squared over u plus some constant c. And that is my answer.
When do we use the absolute value and when do we use just parentheses for ln?
For ln, so really the habit should be to always use absolute value unless you get a number, right? Unless you get like ln of 2, we know ln of 2 is positive because ln is restricted to the positive side. So we really probably should put ln all the time, or absolute value all the time.
Okay, thank you.
Mm-hmm. Is this helpful?
Very.
Yeah.
When we multiply cosecant theta by 1, cosecant theta minus cotangent theta, is that like a rule we're supposed to have memorized?
Are you talking about when I did this piece right here?
Yeah.
Yes, that's the trick to cosecant. And that's why I wanted to do this problem, because I wanted you guys to be able to see that trick.
Is there like a different trick if you have like secant theta or?
Yes, I did that one in the notes.
Oh, okay. Okay.
Here, I'm not going to let you not know it.
Sure.
So if you have secant theta, you multiply by secant theta minus tangent theta. Is it minus? What's the derivative of secant? Secant theta, tangent theta, right?
Yeah.
Yeah.
So let me, here, I'll make sure. Because I want to have the correct substitution for you. Secant theta minus tangent theta. So, nope, it's plus. So for secant theta, you're going to multiply by secant theta plus tangent theta, okay?
Okay.
And the only reason I knew that is because what's the derivative of tangent? It's secant squared theta, and that's positive, so I knew that this had to be a plus.
Got it.
Okay, but that's the trick for secant. This is the trick for cosecant.
One for cotangent?
For cotangent? No.
Yeah,
no. These are the two that have the special trick.
Okay, cool.
All right. Can I erase this? Or you want me to just leave it there?
Whatever.
I'll leave it there because you guys will probably refer to it in the notes. So I'll leave it. Okay, next. What number was that? 6. So let's go on to number 7. Okay, number 7 should be this bad boy. All right, so the integral of x squared plus 14x dx we're kind of stuck, right? Do you guys agree we're stuck?
Yes.
So in order to be able to do this problem, we have to manipulate. What did I do?
You completed the square?
That's it. I completed the square. So what that does for me by completing the square is it allows me to go, okay, x plus 7 squared minus 7 squared is now in the form of the possibility of a trig sum. Does that make sense?
Yes.
Cool. So now the trick on this one, and this one's a little bit more complicated, it's the little twist to the work that we've done. I'm sure you had one in your homework. It becomes x plus 7 is equal to 7 secant theta. So remember in the past we had x was equal to 7 theta, because the x was the only thing that was squared. In this case, we have an x plus 7 squared, so that has to be what's equal to the trig substitution. You guys with me on that?
Yes.
Okay. So when I take the derivative, I'm going to get dx is equal to 7. The derivative of secant is secant theta tangent theta, correct?
Mm-hmm.
Do you guys see how many derivatives you've had to learn and know in chapter 7?
Too many.
It's insane, right? They all come back. You're like, oh my lord.
How do you know to use secant in the first place?
Because of the 3 substitutions that I gave you from, what was that? That was section 7.3.
Okay.
And that's in your notes, right?
Yeah.
So if you just refer to those notes, you'll have those. You can write that down on your cheat sheet for the exam so that you know what trig sub to use. Okay?
Okay.
All right, so now I'm going to do this substitution. So I'm going to go, all right. I'm going to go, I'll go 7 secant theta plus, oops, I'm messing up here, squared minus 7 squared, rooted, right, times 7 secant theta tangent theta d theta. Do we agree?
Yes.
Okay. So then this rooted thing here, doesn't that become 7 tangent theta? Right?
Can you repeat that again?
Doesn't this piece right here become 7 tangent theta?
Yes. Okay.
So then times 7 secant theta tangent theta d theta, which will yield 49 tangent squared theta secant theta d theta. Right? We have an even and an odd function. So in this case, we need to break it down. So I'm going to go 49 integral of, I believe it's secant squared theta minus 1 times secant theta d theta. It's a terrible. Correct?
Correct.
Sorry, someone's calling me. My apologies. I thought my phone was on Do Not Disturb. Okay, so then from here, I'm going to get 49 integral of secant cubed theta minus 49 integral of secant theta d theta. D theta. They both need d theta. Right? And we just talked about this guy. Right?
How did you get the cube?
What is secant squared times secant?
Oh, okay. Oh, you distribute.
Mm-hmm.
Okay.
And we did this one in the notes. Isn't this a repeater?
Yes.
Yes. Yes.
Okay. Do you want me to show all the work for these, or can I just go to the answer? Since you have them both in your notes. It's up to you.
You can go with the answer.
Oh.
That's what I say.
A lot of silence. Okay, well, I'll put the answer. So, oops. So it should be 49 over 2 secant theta tangent theta minus 49 over 2 ln of secant theta plus tangent theta minus 49 ln of secant theta plus tangent theta plus some constant c. This part is the cube. This last one is just secant. Right? That's what I gave you guys when I just did that example up above.
Is the first third of it secant squared, and the middle part is secant?
So here, I'll color coordinate this for you. This one correlates with this. This one correlates with this. And I should have an absolute value there.
I'm saying in the work that we had before, it's two sections because you broke it up into secant squared and secant. Is that correct?
This?
Yeah.
So this, remember, when it's a secant cube, you do break it down, and then it repeats.
Okay.
This is a repeater, and I did do it in your notes before, so you can reference the notes for it. But it should yield this answer. The answer without the 49 in front is 1/2 secant tangent minus 1/2 ln secant tangent plus tangent. Because when you break it up, you're going to end up with the integral of secant again right here, right? That's what this is. Does that make sense, Jason?
What was that?
Does that make sense?
Oh, that wasn't me who asked.
Oh yeah, it was Aaron, wasn't it?
Yeah.
Are you okay with that?
All good.
Okay. And then we still aren't done, right? Because we need to do the triangle. So we have to remember that we have a triangle. And what did we say? It was x, oops. How was I doing that? Sorry. What was it? X plus 7 is equal to 7 secant theta. So that is my secant theta. So secant, remember, is adjacent. Cosine is adjacent over hypotenuse. So this is going to be hypotenuse over adjacent, correct?
Correct.
Okay. All right, how do I want to attack this so you guys get this? Okay. So adjacent, hypotenuse over adjacent. So this should be x plus 7, and this should be 7. And then this here would be the root of x plus 7 squared minus 7 squared, which is what we originally had, which is x squared plus 14x. Cool?
Cool.
All right. So I'll skip so we don't get it cut off by that page. So we're going to get 49 over 2. Secant is going to be that x plus 7 over 7. Tangent is going to be the opposite over the adjacent, so that should be root of x squared plus 14x over the adjacent minus 49 over 2 I'll leave it this way. I don't care. I won't clean it up, even though they're both ln's. 49 over 2. Secant is going to be ln of x plus 7 over 7 minus tangent, which we have already. Right? Minus 49, and it's going to be the exact same thing. X plus 7 over 7 minus the root of x squared plus 14x. That's terrible. Root of x squared plus 14x all over 7, absolute value, plus some constant c.
I have a question.
Yes, sir.
Why is it, subtraction inside the natural log when before it was addition?
Oh, because I like to change signs for fun. Thank you for pointing that out.
I thought I missed a step or something.
Yeah, no worries. So here you guys realize that you could combine these, right?
Yeah, it's well, it'd be division, right?
Yeah, it would be division. Hold on, I want to make sure I have something right. I believe this is actually a plus here. So this should be a plus. Yeah. That was a mistake on my end, sorry. So do you want me to clean it up with the division of the ln's?
Yeah, let's do it.
Alright, so then I'm going to get 1/2 x plus 7 times root of x squared plus 14x minus 49 over 2 ln of x plus 7 over 7 plus root of x squared plus 14x over 7 plus c.
So it just cancels itself out?
Yeah, because what happens here is, look, this is half of what this one is. So it's going to end up being, this is bigger, so it's going to be the other half, but it's got to be a negation.
Okay.
I don't understand why you called it division, isn't it subtraction?
It's, so logarithms, when you subtract, the rule when you put them together into one natural log, you divide them. Right, but this here, all we did was deal with the coefficients, so it really was subtraction.
Okay. Yeah, so it was.
Yeah. Oh, yeah. I get what you're saying. Got it. And this is the answer. Cool?
Cool.
Let's see, did I do this right? I just want to make sure. Secant is hypotenuse over adjacent. Yeah, I'm right. Okay. Just trying to confirm and make sure. All right, what number was that? 7. Let's go to number 8. All right. I'll do one more of these and then move on to the next section. All right, here we go. We haven't even gotten to the fun stuff yet. Isn't that crazy? What does this look like?
I forgot it's called, not expansion, but what is it?
The partial fraction decomposition.
Yeah, it's the essay of a problem, right? Partial fraction decomposition. All right. Here we go. Heck, I'm just going over this with you guys and I'm tired. It's been a minute since I've been a student and had to like be so prepared for a test. It's tiring, isn't it?
Yeah.
A little bit.
I got my master's in math, just so you guys know, 15 years after I graduated from college. A little over 15 years. And my first semester back in school, I was like, oh, it's been a minute since I've done serious math. I asked my wife if I could quit. You know what she said to me? She said to me,
No.
She said to me, she goes, if you quit, you realize our kids are old enough to remember this. And I was like, damn. So I got a master's degree.
I get myself into.
Yeah. So I got a master's degree because I was like, my kids, they got to see me finish. But I was like, oh no, what did I do to myself? Oh well. All right, so let's do this problem. So we see that the factors here, we're going to have a repeater and we're going to have a nonlinear in the denominator, correct? So when we break this down, this x squared minus 14x minus 14 over x minus 1 squared, x squared plus 1 is going to be equal to a over x minus 1 plus b over x minus 1 squared plus cx plus d over x squared plus 1. That's how we break this thing down, correct?
Correct.
Okay. Now we have to do the manipulations, and so we're going to do, okay, we know that this thing, when we do common denominators, will be this, correct?
Correct.
So I'm not going to worry about that. I'm going to worry about getting my A, B, and C, D in with the right numbers with them. So A is going to have an x minus 1 with it and an x squared plus 1. The B is going to need the x squared plus 1, and the cx plus d is going to need x minus 1 squared. That will equal x squared minus 14x minus 9. Do we agree?
Agreed.
All right, so now we have to do this expansion. So I should get ax cubed plus ax minus ax squared minus a plus bx squared plus b plus, oh Lord.
Hey, Professor, wouldn't a have to be multiplied by x minus 1 squared?
Which one are you talking about?
When you multiplied a by everything, shouldn't it be x minus 1 squared because it's already over x minus 1?
X minus 1 squared. Here?
No.
This guy is going to be multiplied only by x minus 1. Because in order for this to have this denominator, I have to multiply the bottom by x minus 1, correct?
Yeah.
So then I have to multiply the top by x minus 1.
Okay.
Does that make sense?
Mm-hmm.
And then I have to multiply by the x squared plus 1. Agreed?
Yeah.
Okay. I'm going to do some side work because I'm good, but I'm not that good. Cx plus d times x squared plus minus 2x plus 1. I'm just trying to do this expansion for you guys correctly. So that's going to be cx cubed minus 2c x squared plus cx plus dx squared minus 2dx plus d. Agreed?
Yeah.
So now I got to write that in. Cx cubed minus 2cx squared plus cx plus dx squared minus 2dx plus d. Okay, now we have to put everything in its terms. So the x cubes, I have 2 of them, right? I have a plus c is equal to the x cubed term. Do I have an x cubed term?
Yes.
A cube term?
Oh,
Over
wait,
here?
no, never mind. Sir.
Yeah, there's not.
No.
So it's equal to 0, right? The x squared is going to be negative a plus b minus 2c plus d. And that should equal 1. Are we in agreement?
Yes.
Is there anyone that needs me to show how I got those?
Can you please show you got that?
Yeah, sure. So check this out. Everything that has x squared. So just so you know, this first one was the x cubed. This is the x squared. The next will be x, and then it'll be a constant, right? So all the x squared terms. There's a negative a, right? A plus b, a minus 2c, and then a plus d. Does that make sense?
Got it. Thank you.
Yeah, dude, totally. Here, I'll highlight the next one. So to get my x's, it's going to be a plus. Ooh, I don't want to use the same kind of color. That's too close. Let me be more.
Yeah, that color coordination helped, by the way.
Okay, cool. Yeah, cool. Nope. Whatever works, right? The a, do we have another x? Plus c minus 2d. Right? So a plus c minus 2d, and that should equal
Negative 14.
that negative 14. And I'll see if I can do this. The coefficient here is 1. That's why I got 1. The coefficient here is negative 14. That's why I got the negative 14. We're good?
Yeah.
All right, with the constant then, it's the ones that don't have a variable. So it's a minus a plus b, and a plus d. So minus a plus b plus d is equal to a negative 9. All right, we okay? Now, for me, I don't want to go through the solving of these equations because this is a pain. I would have plugged this into my calculator using matrices, and you guys should have learned how to do that in your Math 70 course, or probably even in your pre-calc course you did it, right?
Question about that: would for the matrices, or for the matrix, would x to the cube have a coefficient of 0 then?
Yeah, so check this. Yes, the coefficient is 0. That's why I have this as a 0. These are the coefficients. Does that make sense, Aaron?
Yep.
And if you wanted to write it as a matrix, just so you guys can see, here's how it would be written. It'd be 1, 0, 1, 0, 0, negative 1, 1, negative 2, 1, 1, 1, 0, 1, negative 2, negative 14, then negative 1, 1, 0, 1, negative 9. Okay? All right, so let me tell you what the A, B, and C are. A, B, C, and D. I get 5, 11, 5, and a negative 7. Okay. Let me see if I have a TI.
Okay.
Hold on one second. I want to get a TI to show you this real quick. Hold on. Okay, I want to do this for you guys because I think it's worthwhile. Those of you who have a TI-84, it's too bad I can't show you this emulator in person, or if I had an emulator on my computer. But I'm going to tell you guys the steps to do this, and I'll write it on here so you guys can do this, okay? So the first thing that you're going to do, obviously turn your calculator on, but you're going to go second, the negative 1. So on your TI, you're going to go second, and then it's the button X to the negative 1, and above it in blue, or in some, it should say matrix. Okay, so if you guys have your calculator, pull it out. I want you guys to be able to do this, okay? Then what you're going to want to do is it will show a table that shows like matrix A, matrix B, matrix C. You guys should see this, right? What you're going to want to do then is go to Edit, and then pick the matrix you want to do. Typically it's matrix A. Okay? Now when that comes up, it's going to give you matrix A, so you should see matrix A, and then it's going to give you dimensions, right? So the dimensions of the matrix that we have here is a 4 by 5.
4 by 4.
4 by 5. So then you're going to want to make it a 4 by 5 for this case, because it's 4 by 5 columns. 4 rows by 5 columns. Does that make sense? So this matrix, this matrix in this case is a 4 by 5 matrix. Okay? And I'm recording this so you guys can rewatch this if you need to. So once we have the 4 by 5, we're going to input the values. Now you input your values. Okay, so let me do that on my calculator. So it should be, I'm going to go 1, 0, 1, 0, 0. And the way you do it is you type your number, then enter, type your number, then enter, or you can even just scroll to the right and left. I typically just enter.
I got the same values, but the signs are different.
Okay, hold on a second. Let me do it. Negative 1, 1, 0, 1, negative 9. Okay, once you have those values, you can second mode, which will quit out of it. Okay? So these are all the steps. 1, 2, 3, 4, 5, 6. Then we'll go back to the matrix again. So you'll go back to second x to the negative 1 to get back to the matrix, right? Hold on, let me make sure I'm right. Yes, you'll go second matrix, and then you're going to shift to the right to math, highlight math. Okay, then there should be a list, and you're going to want to go R, R, E, F, and hit enter. And then 9, you're going to again go second the matrix button and select your matrix A. And then enter. And I got, oh, so maybe my matrix is wrong. I got 1, 0, 0, 0, 5, 0, 1, 0, 0, negative 11, 0, 0, 1, 0, negative 5, and 0, 0, 0, 1, 7.
That's what I got.
Okay.
That's the same thing.
Okay, so now your A here is 5, your B is negative 11, your C is negative 5, your D is 7. So I obviously I'd gotten the wrong value, so I got to fix that. What did I have? 5, negative 11, negative 5, and a positive 7. Okay, that will save you time in terms of trying to solve your matrices. Okay, in terms of trying to solve your matrices. And so now when I go to do this thing, remember the integral that we had is going to be the integral of 5 over x minus 1 plus, or we can say minus, because now we have minus 11 over x minus 1 squared. If I do a minus here, I'm going to get 5x, and then these have to switch signs. I believe that's plus 1. Yeah, dx. And that's the matrix that we're given. Are we okay?
Was it 5x plus 7 or 5x minus 7?
You mean right here? Because of the minus sign, that's like a distribution. That becomes a negative, and that would become a plus.
Oh, okay.
Does that make sense?
Yeah.
Okay. So now this integral is something we can handle. And so the first integral is going to be 5 ln of x minus 1. Agreed? The next one would be plus 11 x minus 1 to the negative 1, just using power rule. And then the next one, I'm going to break it up into two integrals, okay? So I'll do that so you guys can see those two integrals. It's the integral of 5x over x squared plus 1 dx plus the integral of 7 over x squared plus 1 dx. Right? How I got this one was power rule. This was just ln. Agreed?
Agreed.
Okay. Now, this third integral is just going to be a u sub, right? I'll write this clean. And then this one here, since it's a u sub, I'm going to get 5 over 2 ln of x squared plus 1. And then that last one is a trig inverse, right? So I'm going to get plus tan inverse of x plus my constant c. Ooh, I forgot the 7 in front. We okay?
What was your U for that U sub? Just so I can write it down.
For this one?
Yeah.
Okay, so I'll show you that one just so you can see. I would have gone u is x squared plus 1. So du is 2x dx. So 1/2 du is the x dx. And so I would have had 5 over 2 integral of 1 over u du, which is the ln. Does that make sense?
Yeah, I was just wondering what you.
But I recorded how to do the integrals and how to solve for them. That RREF is called the reduced row echelon form. Don't worry about it. It just makes it so that it's the identity matrix. All right, can I erase this U sub stuff?
Not yet.
Okay.
Okay, you can erase it now.
All right. Anyone else? Okay, I'll erase it. Let me see, what number was I on? So that was number 8. So I'll do 2 more problems. So you guys can see, I mean, I'm probably going to give you 10 problems on the test, and they're going to take your time. Right? I mean, look, I've done, gotta plug in my computer. I've done, what, 8 full problems every step, and it's taken me already over an hour and a half. So I think 10 questions is about the limit for this exam. What do you guys think?
And I think 10 questions would be good.
Yeah.
Yeah.
Okay. So I'm always going to ask a question where you have to do Simpson and midpoint and trapezoid. So I'll give you one of those because I think that's worthwhile. And then I'll give you obviously a convergence divergence problem. So let's delve into the converge diverge. So, or let's do the trapezoidal. So if I give you an integral from 1 to 4 of 7 square root of ln of x dx. And I say, all right, my n is 6. I want the 3 approximations for this, right? So I'm going to want trapezoid. And so with the trapezoidal rule, what do we know about the trapezoidal rule? We need to be able to find our delta x first, right? So what is the delta x in this problem?
4 minus 1 over 6.
Oh, 4 minus 1 over 6, perfect. So 4 minus 1 over 6, which will give me 1/2, correct?
Correct.
And then the trapezoidal rule tells us if I'm going to go after a trapezoid for 6, I'm going to get 1/2 divided by 2, right? And then we have to remember it's f1 plus 2 times f2 plus 2 times 1.5 because we're incrementing by 1/2. So we have to go the gambit from start to finish. So I'll write that down just so you guys have it. Ooh, let's not forget the 2.
On the exam, do you want us to write it like that? Like every step, and then like include every decimal. On WebAssign, it wants like every decimal, like it's like
they'll tell you how many decimal places, right? So since the exam's gonna be on WebAssign, I would yield to what WebAssign has. So yeah. So in this problem, on WebAssign they ask for 6 decimal places. So I would do everything to 7 decimal places, and then when at the end round. Or in fact, I wouldn't round until the very end. Does that make sense?
Yeah, because
if you round at all before, you're gonna get it wrong.
that kept happening to me.
Yeah, so don't do that. You'll get it wrong. So since you have a TI-83, just put in all 6 of those values in. 1, 2, 3, 4, 5, 6, 7 of those values in. And then at the end, when it asks you for the 6 decimal places, round that 6th decimal place. So in this case, this one would have been 18.139337. That's the approximation for the trapezoid rule, right? That's just calculator work. It's not anything that I need to show. Now, does everyone know where to plug in F1 and F2 and all of that? Is there any question on where to plug in? Because that's important.
Just make sure I get it. For example, if we're doing F1, it's 7 to root of ln.
Correct. This is my function.
Okay.
So perfect, yeah. So I'd plug in 1 into here and then do this one, 1.5 into this one, 2 into this one, remembering to multiply by 2, right? All right. The midpoint. Midpoint, we know that it is delta x, and then it's the increments, right? But now, when we do this for the midpoint, we're going to find what is the midpoint between each of the delta x's. So if I started at 1 and I had a delta x of 0.5, halfway between them would be f of 1.25, correct?
Correct.
Then the next one, now we don't have to think anymore. We just add half. So this should be 0.75. And then add a half. So that should be 2.25. And then f of 2.75. And then plus f of 3.25. That's sloppy, I can't have that. And then the last one should be f of 3.75. Agreed? Okay, and then this one, you guys can check with your calculators. Again, don't round till the very end. It's 18.767319. Right? You guys should write down trapezoidal and midpoint rules and Simpsons. So now we'll do Simpsons for 6. And remember, why is Simpsons so useful? Simpsons is useful because it takes curves for curves, right? So that makes it a little bit better. So then when we do this one, we remember it's going to be 1/2 divided by 3. And then we just simply go f of 1 plus f of 1.5. But remember, we have to alternate our values, 4, 2, 4, 2, right?
That over 3 is fixed, right? It's part of the rule.
Correct. Yeah, this is fixed for Simpsons. This is fixed for trapezoid.
Wait, sorry, what did you say was fixed for trapezoid? I was looking down.
I'm sorry, say that again?
What did you say was fixed for trapezoid?
Trapezoid, the 2.
Okay.
This 2 down below is fixed.
And then for midpoint, that 1/2 was just the delta x.
No. Yeah, the 1/2 is, ooh, dang it. Not the highlighter. The 1/2 of above is delta x over 2, and then in Simpsons it's delta x over 3. Okay? And then I need 4f of 3.5, and then plus f of 4. And then with your calculator approximation, 18.428. Oopsie daisy, I messed up. 3834. But again, that is only using the formulas in your calculator. So actually, when you do Simpsons or midpoint or trapezoid, you guys should be very happy. It's just, all right, do I get the operation and then just type it in my calculator, right?
Yeah, so you only want this much, so this much work is acceptable.
Totally.
Okay, cool.
Yeah. This would be my justification for the work. I don't need to see that you typed in every number and give me 58 million decimals.
Thank God.
That would kill me, man.
Yep, me too.
Look, I understand. I've told you can use your TI-84. Use that bad boy, right? All right, let's do our last example. And then I can try to answer some homework questions if you guys have homework questions. Or if you guys are spent, we can meet tomorrow during my office hours and I can do problems and post them for you guys however you guys want. I get it either way. All right, this is number 10. And my question is going to be something like determine whether the integral is convergent or divergent. All right, you guys ready?
Yep.
Which one do I want to do? Let's do this one. Okay, so the integral from negative infinity to 0 of z over z to the fourth plus 9 dz. We need to decide if this converges, diverges, or what the heck, right? Now, if it diverges in WebAssign, does it just have you spell out diverges? Or you probably haven't even done that homework yet.
I'm pretty sure we'll have it say diverging.
Okay.
Like we'll put the word if it's that.
And if it converges, they just want the numerical value, correct?
Yes.
Yeah.
Okay, so let's do this so you guys can see. So since we have this issue, we're going to have to take a limit of this, right? So it's going to be the limit. Let's use t. That's what I did when I did it for you guys in class. From 0 to t, or from t to 0, I'm sorry, of z over z to the fourth plus 9 dz. So when we do this integral, what can we do? How do I want to integrate this bad boy? All right, let me make my life easy. So let's
Wait,
say
Professor?
u was z squared. Yeah?
Didn't you say it was z to the fourth plus 9z?
No,
I
just
got it.
plus 9. dz is what I said.
Okay.
So I'm going to do it this way just so you guys can see something. So my du is going to be 2z dz, right? So I'll get 1/2 du is z dz.
Are we using t or z?
Oh, I'm doing a u sub first.
Oh, okay.
So I'm setting this up so that I can do something, okay? And you'll see in a second. So my limit as t goes to, in fact, I won't even do that. Let me just do the integral piece. When I do this, I'm going to get 1/2 the integral. The z dz is going to go away, right? So that's going to be du. In fact, I'll write it pretty. Don't I get 1 over u squared plus 9 du? Yes?
Yes.
Okay, what does the integral of 1 over u squared plus 9 look like?
Tan inverse.
Tan inverse, exactly. So I'm now going to go the limit as t goes to negative infinity of 1/2 times 1/3 tan inverse of z squared over 3, right? That evaluated from t to 0. Do you guys agree?
Can you explain where the 1/3 came from?
Yeah. So remember with the tan inverse, it's the rule for tan inverse, if we had it, right? If we had like x squared plus a squared, it's 1 over a tan inverse of x over a.
Okay, it's the root of 9. And then I got it.
Does that make sense?
Yeah, I did see that.
Yeah. That's the rule. All right, and then from there, I'm going to go, okay, the limit as t goes to negative infinity of 1/6 tan inverse of z squared over 3 from t to 0. So I'm going to get the limit as t goes to negative infinity of 1/6 tan inverse of 0 squared over 3 minus tan inverse of t squared over 3. Correct?
Correct.
Okay. What is tan inverse of 0? Not everyone at once.
0.
It's 0. So we'll get 1/6 0 minus my tan inverse of t squared over 3. Right? And tan inverse, when it goes to negative infinity, what is that going to be? Here, I'll clean it up for you guys just so you guys can see. Do you need some help? Remember, tan inverse is restricted from negative 2 pi to 2 pi, correct?
Yes.
So if it's restricted from negative 2 pi to 2 pi, that means that we're looking at this.
So it diverges, right? Because the limit with the infinity.
Well, remember, it's asking you here tan inverse of some infinity, positive infinity, is the same as when is tangent of whatever positive infinity. So when is tangent restricted from negative pi over 2 to pi over 2, positive infinity?
Pi over 2.
At pi over 2. So we get negative 1/6 times pi over 2, which yields a negative pi over 12, and hence a convergence.
Where do we go from negative infinity to positive infinity then? How do we get that?
Oh, why did this become positive infinity?
Because t is going to negative infinity.
Okay, so what happens to the sign when it's squared?
Oh, okay. Got it.
So that takes us to this side, right? So tan, it's saying when is tan equal to infinity? It's over here. So do you see how like a test like this incorporates algebra, algebra 2, trig, your pre-cal, calc 1. It's sad, right? But it's a bunch of work. Are we okay?
Yes.
All right. All right. Should I stop recording here so that I can just answer homework questions so that this doesn't get confused with the homework? Is that okay?
Yes.
All right. I'll stop recording. Hold on.